Okay, here we will see the rational numbers. See, the natural numbers are the 1, 2, 3, 4. That is without 0. Whole numbers include 0 plus natural numbers. That is 0, 1, 2, 3. Whole numbers. Okay, whole numbers having 0, but natural numbers there is no 0. Integers having both whole numbers and natural numbers. Okay, minus 3, minus 2, minus 1. This also includes 0. So why do you need a rational number? Here we have fractions like this 3 by 4, minus 3 by 4, whatever it is. But in fraction we won't have a negative sign. So we need a rational number to represent such a negative fractional numbers. So here you see minus 3 by 4, this is a rational number. So in fractional numbers we don't have that negative sign, all are positive sign only. So we use the rational number. So what are the rational number? Rational number is of the form p by q, where p and q are integers and q is not equal to 0. Q is not equal to 0. That is important. Okay. In the form p by q, p is the numerator and q is the denominator, which is not equal to 0. So say example minus 3 by 7. The minus 3 is the numerator and denominator is 7. See, any integer can thought of a rational number. So if you say minus 5 can be written as minus by 1. So this is also a rational number. The integer 0 is also a rational number because 0 can be written as 0 by 7. See, here 0 is on top, not at the bottom. So p by q should not be 0, but p can be 0. Okay, 0 by 7. So 0 is also a rational number. These rational numbers include integers and fractions. Okay, here numerators and denominators consider minus. Here see what they have done. Minus 2 by 3, they multiplied numerator and denominator by 2. So this is also another form of this minus 2 by 3. Okay, in different form. So you can also multiply by minus 1, minus 2 by 3, minus 5, minus 5. Minus minus will become plus. So 10 by minus 15. So this minus sign can be anywhere. 10 by minus 15 is same as minus 10 by 15, because if you multiply by minus 1 on the top numerator and the denominator also by minus 1, this will become minus and this will be plus. Okay. By multiplying the numerator and the denominator of a rational number by the same non-zero integer, that is here I multiply minus 1, that is also non-zero integer, we obtain another rational number equivalent to the given rational number. The both are same. 10 by minus 15 is same as minus 10 by 15. We are multiplying minus 1, 10 into minus 1, minus 15 into minus 1. So here you see they given they fill in this box. So 4 becomes 16. That is 4 times 4 is 16. So 5 times 4 is 20. Then 5 becomes 25. 5 into 5 25. So 5 into 4 20. And 5 become minus 15. So we are multiplying by minus 3. So that means here it will become minus 12. Minus 3 by 7, 7 becomes 14. That means multiplying by 2. So minus 3 into 2, minus 6. Minus 3 has become 9. That means sign change is negative become positive. So we have to multiply a negative number, minus 3. Minus 3 into minus 3, 9. So 7 into minus 3, minus 21. Minus 3 has become minus 6. That means multiplying by 2. So this will become 14. Positive and the negative rational number. See, this is a positive rational number. 2 by 3 is a positive rational number. And a negative rational number, you can have negative sign either in the numerator or in the denominator. So these all are in the negative rational number. Okay, so it can be numerator or denominator. The number, see here we have a minus sign in the denominator. This is also a negative rational number. See, number 0 is neither a positive nor a negative rational number. So 0 is not a positive rational number or not a negative rational number. Minus 3 by 5, because numerator denominator minus sign will cancel out, then it will become a positive rational number. So classify these things with a negative rational number. This is a negative rational number. This is positive. This is also negative. Minus sign can be anywhere. This is neither a positive nor a negative. 0 is neither positive nor negative. This is a positive, and this is also positive because 2 minus sign will cancel out. Numerator and denominator signs will cancel out. This is positive rational number. Rational numbers on a number line. Okay, so this is a number line. The right side of 0 is a positive number, left side of the 0 is a negative numbers. Okay, so now you can go through it. I will show you some example of how mark minus 5 by 2 and minus 7 by 2 in a number line. Okay, I will show you how the number line looks. See, first you take minus 5 by 2. Okay, so this is a negative sign, so it has to be left of 0. So this number has to be left of 0, and here denominator is 2. That means there are two parts between the integers. That means 0 minus 1, between them there are two parts. Here see, this is 0 and this is minus 1, one part, two part. So here this denominator 2 means there are two parts. Okay, now if you want to write, you can write this form, in this form. Minus 5 you can write in minus 2 into 1 by 2. This is also minus 5 by 2. 2 into 2 4, 4 plus 1 5 by 2. But without that also you can mark. So only thing you have to remember, two parts between the integers. So 0 minus 1, there is two part, and minus 1 minus 2, there is two parts. So now minus 5 by 2, from 0 you start, 1 by minus 1 by 2, minus 2 by 2 will become minus 1. Okay, minus 3 by 2, minus 4 by 2 again will become minus 2, minus 4 by 2 will become minus 2. This is minus 5 by 2. So this is on the number line. Okay, minus 5 by 2 is here. Okay, same way you can mark for the 7 by 3. This is a positive number. I have taken the positive number. Okay, that means it will come right of 0. Okay, right side of the 0, and there are three parts between 0 and 1. 0 and 1, they have to mention three parts. Okay, this is 0, one part, two part, three part. Okay, here also you can simplify it like this, 2 into 1 by 3. Whenever you see numerator is greater than the denominator, you can simplify. Without simplify also you can put. Okay, so after 0, this is 1 by 3, 2 by 3, 3 by 3 will become 1. Okay, 4 by 3, 5 by 3, 6 by 3 will become 2. So this is 7 by 3. Okay, 7 by 3, that is a positive number, it comes right. Okay, so I have shown you how to represent this in the number line. I have taken 7 by 3 here, minus 7 by 2. You can apply the same logic here. In the standard form, these numbers on the standard form, you see negative sign is the on the numerator only, not denominator. Okay, the denominator of these rational numbers are positive integers. Okay, denominator positive integer, and 1 is the only one common factor between the numerator and denominator. That means we cannot simplify it further. 3 by 5 we cannot simplify it further. Minus 5 by 8 cannot be simplified further. So that is what they are saying. 1 is the only common factor between the numerator and denominator. Further, the negative sign occurs only in the numerator. Here numerator only will have the negative. This is the standard form. Okay. A rational number is said to be in the standard form if the denominator is a positive integer and the numerator and the denominator have a common factor of have no common factor other than 1. Okay. So here you have to write in the standard form. In the standard form, you can divide by the first there because if you know it is divisible by 15, you can directly do it. But if you don't know directly, then first you divide it by 2 or 3. This can be divided by 2 because this is a odd number. So divided by 3, then divided by 5. Thus, to reduce a rational number to the standard form, we divide the numerator and denominator by their HCF, ignoring the negative sign. If any, the reason for ignoring the negative sign will be in higher classes. Okay. Okay. This is so now I will show you how to simplify this in the notebook. So here see minus 18 by 45. That first I divided by 3. So minus 18 become minus 6. Then this become 45. Then again we can divide it by 3. Minus 6 minus 2. Then 15 becomes 5. Okay. Same minus 12 by 18. First I am dividing by 2. Then I am dividing by 3. So you can do it. Okay. See this minus 8 by 3 I am representing in the number line. Okay. So because it's a negative, so you have to do it on the left side of the 0. And there are three parts between 0 and minus 1. Okay. 0 and minus 1 here. 1, 2, 3 parts. Okay. Now this is 8 by 3. Minus 8 by 3. Minus 1 by 3, minus 2 by 3, minus 3 by 3 will become minus 1, minus 4 by 3, minus 5 by 3, minus 6 by 3 will become minus 2, 7 by 3, minus 8 by 3. Okay. So you can write this is the simplified form is just to inform you that this number will come after minus 2. See here, this is minus 2. After that only minus 8 by 3 comes. See minus 2 into 2 by 3. After minus 2, 1, 2. Okay. 2 by 3. Comparison of the rational numbers, you can compare it if the denominator is same, we can directly compare. Otherwise you have to find the LCM and then compare. Okay. So here you see compare this LCM is 12. So the 12 minus 3 by 4 will become minus 9 by 12 and minus 2 by 3 will become minus 8 by 12. So same way this also 15 LCM you can do like this. Okay, here which is greater? Between these two, this 56 is the LCM. So 56 LCM, this 2 by 3 by 8 will become 3 into 7, 21 by 56, negative minus 21 by 56. Okay, then 2 by 7 will become minus 16 by 56. So minus 16 by 56 is greater than minus 21 by this is a negative number, so this is greater than this. Okay, same way between 3 and 2, 6 is the LCM. So then now the first will become minus 8 by 6, that is greater than the minus 9 by 6. This is 3 by 2 is 9 by 6. Okay, here This example, my minus sign is either as numerator and denominator, both are same. Okay, here it is in the denominator, is new denominator, both represents the same. Rational number between the two rational number. Are there any integer between minus 2 and minus 3? There is no integer between minus 3 and minus 2. Because between two successive integers, the number of integers is 0. Okay. We can find the number of integer between two integers is limited. So we can say whether it is there or not. But the rational number between the number of rational number between the rational number is not a limited one. Okay, it depends on the LCM. So here you see between the 5 and 3, if you take LCM as 15, then there are some number at between. But if you take LCM that 30, between 5 and 3, if you take LCM as 30, then there will be more numbers between the rational numbers. So it depends on the LCM. We can find unlimited number of rational numbers between any two rational numbers. Okay, between minus 5 by 7 and minus 3 by 8. Minus 5 by 7 minus 3 by 8. Okay, so we have to find the LCM. So minus 5 by 7 will become minus 40 by 56. Minus 3 by 8 will become minus 21 by 56. And so the 5 rational number between them, I have just taken some numbers. You have to find the LCM and write. Okay. List 3 rational number between minus 2 and minus 1. Minus 2 and minus 1, because we need 3 rational numbers, we are multiplying the numerator and denominator by 5. Okay, minus 1 will become minus 5 by 5, minus 2 will become minus 10 by 5. So in between these are the rational numbers, we can use these. So minus 1 and 0. See, between minus 1, 0, so I am multiplying 0 by 6 and dividing by 6, 0 by 6, 0. And minus 1 also I am multiplying numerator denominator by 6. So minus 6 by 6. So between that, so you will see minus 1 by 6, minus 2 by 6, minus 3 by 6. So these are the 5 rational numbers. So okay, 0 is also a rational number. So between minus 1 0, these are the 5 rational numbers. So because we need 5 rational numbers between, I multiplied it by 6. Here you see between minus half and 2 by 3. See here between minus and half 2 by 3, LCM is 6. Okay, LCM is 6. So here minus half will become minus 3 by 6, and this 2 by 3 will become 4 by 6. So this itself you will have a lot of numbers between them, 5 numbers. So minus 2 by 6, minus 1 by 6, 0, 0 by 6, that is 0, 1 by 6, 2 by 6. Okay. So this is the number between these two numbers, minus 3 by 6 and 4 by 6. From negative it goes to the positive. Here this LCM itself is enough. We don't have to multiply any other number. Okay, for this. Draw the number line. Okay, I already shown you how you can do the number line with these 8 parts, 4 parts. Okay. So here you see minus 5 by 8. So this is a negative number. So it has to be left side of the 0. Then there are 8 parts, okay, between 0 and minus 1. This is 0 This is my now there are 8 parts. Minus 1, 2, 3, 4, 5, 6, 7, 8 parts. Okay, minus 5 by 8 we have to represent. Minus 1 by 8, 2 by 8, 3 by 8, 4 by 8, minus 5 by 8. Okay, now you see minus 7 by 4. So here you will see the numerator is greater than the denominator. So I simplify it. With that simplify also you can put negative number left of 0, and there are 4 parts between 0 and minus 1. Okay, 1, 2, 3, 4. Okay, now we have to mention minus 7 by 4. 1 by 4, 2 by 4, 3 by 4, 4 by 4, minus 5 by 4 is minus 6, minus 7 by 4. Okay. Now you see they are given the points. Okay, now you see they are asking the value of PQRS. Okay, now between the two integer there are 3 parts, 1, 2, 3. So here, so 3 parts here, 3 parts here, 6 parts, and so this is the 7 by 3. Okay, P is 7 by 3 because there are already these 3 parts between the integers. Okay, 3 parts here, 3 parts here, 6, then this is 7, 7 by 3. Okay, then Q is 8 by 3. Similarly, this side, 3 parts here, so minus 4 by 3 minus 5 by 3. Okay, minus 4 by 3 minus 5 by 3. Which of the following pairs represent the same rational number? Okay, this is same, minus 2 by 3 and 2 by 3, because sign will cancel out, negative signs numerator and denominator. And this is also same. Okay, because this is 4 times of this is minus 12 by 20, and this is also same because we are multiplying this by minus 3, minus 3 into 8 minus 24, minus 3 into minus by 15. Okay, so here I have put the less than greater than symbol. You can go through. This is minus 7 by 5, minus 5 by 7 is less than 2. You have to find the LCM actually. Okay, here this here for this case you don't have to find LCM also. This is a positive number, this is negative number. Obviously 2 by 3 is greater than the minus 5 by 7. For other things I have mentioned LCM and given. See here, these are equal symbols. Minus 7 by 8 and 14, these two are equal. You find the LCM and do, this will become minus 14 by 16. This is also minus 14 by 16. Okay, see which is greater, I mean on the number line you have to draw which is on the right side of the number line is greater than the left side. Okay, that's how you have to compare the numbers. Operation on the number line. Okay, so this operation on the number line, the addition, you can do this fraction addition only. There is nothing special here. You can add just like what you have learned in the fractional addition. Only thing we have to represent that result in the number line. Okay, so how to represent the number line I already given you, I already told you. So in the addition, while adding the rational numbers with the same denominator, we add the numerators, keeping the denominator the same. See here, when these two 7, 7 means only the numerator we will add. Minus 13 plus 6 will become minus 7. Okay, minus this 5 is the denominator. Minus 11 plus 7 is minus 4. But if the denominators are different, you have to find the LCM, then we have to add. So like you did in the fractions. Okay. For rational number, we call minus 4 by 7 as a additive inverse of 4 by 7. When you add a number with that additive inverse, then result will become 0. Okay. Okay. See here, this person walks 2 by 3 kilometer from place B towards east, then this one 5 by 7 kilometer towards west, we, where will he be from point P? Okay, they mentioned. So this is, you see, you have to know the east west, east west north south. So from point P he goes towards east 2 by 3 kilometer, and again walks back from here, walks back with one this many kilometers. Okay, 12 by 7, 12 by 7, they have given the, I have given, they have given the mixed fraction, I converted it. See, 1 5 by 7 is 7 plus 5, 12 by 7. Okay, now this is on the walking backwards, so you have to put a negative sign and add. Okay, then we find the LCM as 21. 21, this will become 14 by 21 minus 36 by 21. Okay, minus 22 by 21, then after the simplification you can write in the mixed fraction like this. So he is now minus 1 by 21 kilometer from B. Okay, this is point B, so this side is now left side, minus 1 by 1 into 1 by 27. Subtraction also you can do, but the only thing is the denominator is different, than you have to find the LCM. We say that while subtracting two rational numbers, we add the additive inverse of the rational number that is being subtracted to the other rational numbers. Multiplication, you can first multiply, then show it on the number line. Okay, first minus 3 by 5 means by 2, that means minus 6 by 5, then minus 6 by 5 you show it on the number line. While multiplying the rational number by a positive integer, we multiply the numerator by the integer numerator only, keeping the denominator unchanged. Okay, but if you are multiplying with a fractional number, then you have to multiply like this: minus 3 by 8 into 5 by 7. We have to multiply numerator as well as denominator. Division, here if you divide one rational number by other, you have to take the reciprocal of it and multiply it. Okay, so here you multiply 4 by 7, reciprocal of 4 by 9. Okay, this will become my 4 into 9, 36. Here also 36, the signs will cancel out. Okay, see here 4 by 9 divided by minus 5 by 7. So 4 by 9 they are written as it is, and this we are taking reciprocal and multiplying. Minus 5 by 7 will become 7 by minus 5. So this is the answer. Multiply one rational by rational number by the other non-zero rational number. We multiply the rational number by the reciprocal of the other. Okay, okay, that is the end. You can try out this sample yourself. Okay, the summary also you can read. Whatever p by q is not equal to 0. Here numerator and denominator can be a negative integer. For the negative rational number, numerator or denominator, either one of them can have a negative sign. Okay.